Hi, Math 2 Enhanced. So this is your Unit 6 review lessons 1 to 8, and I was going to go through and give a few hints on some of these problems. The solutions are already in the locker, so you can check that to see what questions you might have, and then you can maybe find some tips in this video on that particular question. So first of all, this first question is reviewing on page 10, question number 1. So they ask us to reflect triangle ABC over the line x equals -6. X equals -6 is a vertical line at x equals -6. And as a reminder, y equals a number would be a horizontal line at that number on the y-axis. So to reflect this over, I would just count for my points for my A prime and my C prime, and I would be able to reflect this over the line x equals -6. As a reminder, to do a translation, I can write it a couple ways. The first way we saw it as a directed line segment, for example, 0, 0 to 4, 1. But I'm not really physically moving the blue one from 0, 0 to 4, 1 because it's not at 0, 0. However, the movement from 0, 0 to 4, 1 is a movement of 4 to the right and 1 up. So I am moving the blue triangle 4 to the right and 1 up. We also wrote that as moving my coordinate to its image, x plus 4, in this case, and y plus 1. And if those had been negative numbers, then I'd be moving down, for instance, or to the left. So I want to move 4 to the right, 1, 2, 3, 4, and up 1 for my C double prime. 1, 2, 3, 4, and up 1. And I'll do the same thing for my B, 1, 2, 3, 4, and up 1. And I will connect those, and then I will have my coordinates for A prime, A double prime, B double prime, and C double prime. On the second one, this is like number 3 on page 11. You need to go through and find the coordinates of A, B, and C. You need to do the same thing for D, E, and F. And then you need to write a sequence of transformations that takes this triangle onto this one, and the answers will vary. For example, I'll do it a different way than I did in the locker. You could translate, for example, C to F. So I'm going to translate from C to F, and then I'm going to rotate around F where they're touching. And I could say it a couple different ways. When I move C to F, this is actually a 90-degree clockwise rotation. I could also say to rotate until A lines up with D, for instance. So I could say until A lines up with D. That's a flashback from last September, October in our class. You could also say 90 degrees clockwise. So there are some options with how you could say that second line. So then this problem is actually the same problem as page 11, number 4. And you had 2 different methods to do this. And if I could just bring the key over. So first of all, it's already in the locker. This is different, but there was 2 different methods. You could show that the corresponding sides, for example, CA and FD, you could show that they are exactly the same length, either using our distance formula and the coordinates, or we also learned how to create a Pythagorean, we learned how to make a right triangle and use the Pythagorean theorem to calculate the distance, I believe on page 6 of our workbook. It was the very first activity you and I did together in lesson 1. Another way is to show a translation. So you could talk about how you could move this and then translate it or rotate it, or even sometimes it's a reflection, to get them to line up on top of each other. So there are some examples in the locker here, and there's also the original problem on page 11, number 4. So then this problem is similar to the on page 21, number 5. It's also similar to our number 1 on this worksheet. The difference is, to begin, it's y equals -1. So y equals -1 will be a horizontal line at y equals -1. And then you can do the rest of the problem. So this particular problem, I had some formatting issues. I'm not sure why, but I had difficulty making these numbers while keeping this column the letters. So anyway, sorry if that's confusing when you first look at it. I changed it in my key as well. So this is when you're matching up. In this case, we have 4 translations. I know that because I'm just adding or subtracting a number from my x and y coordinate. And we have 1 dilation. And you're matching them up with what goes together. So for example, on D, I notice I'm going to leave the x coordinate alone, but I'm going to take 4 away from the y coordinate. That's the same thing as translating from the origin and not changing my x coordinate, but taking 4 away from my y coordinate. So I know that D goes with number 4, for instance. So then how about number 19, number 2? This problem, I'm sorry, this is number 6. It's like on page 19, number 2. So in this problem, you're going to want to create a table for problem A, and you're going to need another table for problem B. Remember, on one column, that's my original, and on my other column, that's my image, my transformation. In this case, I need to go through, I'm going to have 3 rows, because I have 3 points A, B, and C. And so I would go get each one of those. For example, A is 2, 3. And then I do whatever my transformation is. In this case, it's telling me to take 2 away from my x coordinate and add 1 to my y coordinate. So that would give me 0, 4. So my A prime that I would graph would be at 0, 4. And I would do the same thing for B and the same thing for C. And then I would have my new graph that I can label as my result T on my graph, my new triangle. And I would do the same thing for the second one. I would have my XY column, which are the same ones because it's the same A, B, and C. And then my prime column would be making my x coordinate negative and my y coordinate stays the same. That would be a reflection in the y-axis, and my triangle would be over here, and I would label it R. And those answers are also in the locker. So this next page, they're given the table, and you're supposed to decide what type of transformation it is or what the rule is. You can find help on those on page 28 of our workbooks. And if you don't have your workbook at home with you, remember the filled in version of our assignments are still in the locker under Unit 6, and you can also refresh your memory there. So then number 9 is like on page 29, number 4. It says that here are some transformation rules, and you're supposed to predict what it looks like, then compute the coordinates of the image, make a table, and draw it. So you'll need to have 3 tables here. So for example, I'll have a table for A, where in my first column, I'll have my 3 points, A, B, and C. And then my image column will be x minus 2. Whoops, sorry, I didn't mean to draw that there. And y plus 1. So I would have my image coordinates. I would graph my image coordinates, and then I would connect them, and that would be A finished. I do the same for B and the same for C. So then going on with 10. This is like on page 58, number 2. So you actually have 2 methods to do this. On page 58, number 2, we use the distance method. We calculated the distance. This point, 1, -2 is from 6, 2. We did that here with the distance formula. That's the distance the point is from the focus. This is my focus. And then we also calculated the distance this point is from the directrix. This is my directrix. You do have a second method, since we've already done lesson 8 at this point in time. You can also write the equation of this parabola. So for example, parabolas that have a focus of AB and a directrix of y equals k have a formula x minus a squared plus y minus b squared equals y minus k squared. You could write the equation of this So in other words, the equation of this parabola is x minus 6 squared plus y minus 2 squared equals y minus 4 squared. And so another method you could use is you could plug in a 1 for your x, a negative 2 into the 2 places for your y, and you could see if both sides of your equation are true. If they are, then this point is on that parabola. So you have two different methods. If you look at the answer key in the locker, I showed you how to use the method of writing the equation and substituting it in. If you're more interested in using the method where you find the distance from the focus with the distance formula and you see if it's the same as the distance to the directrix, then you'll find that work on page 58 of our workbook for question 2. So this is really refreshing your memory on that. And you could use either method, but I will say originally when we did the problem, we did the method where we used the distance formula and the distance from the directrix, but I wanted to offer this one up because I think that this is a really nice way to do that problem. So number 11 was difficult when we did this. I believe it's page 58, number 3, but I didn't write it down here, sorry. So again, you can write the equation of this. So if this is my focus AB and this is my directrix y equals k, then this is my x minus a, so x plus 1 squared, plus y minus b, which would make it a y plus 7 squared, equals y minus 3 squared. And so you can easily see that that's b. So now I need to figure out which one of these equations. This is my vertex form. This is my vertex form we learned in Math 1 last year. So I actually need to do algebra to determine this. So first of all, this is when we're going to leave our x term alone, because notice that there is an x plus 1 squared in all of our answers. But you're going to need to either box or FOIL these binomials out. So I'm looking at x plus 1 squared plus, this would give me y plus 14y plus 49 equals y squared minus 6y plus 9. And this is where, that was a y squared, sorry. This is where we can cancel our y squareds, and my job is to solve for y. So this is algebra from here on out. The algebra is on this answer key, as well as in the locker, page 58, number 3. So go back through and refresh your memory. If you have trouble with that, come see me in one of our office hours. So now I'm going to be talking about circles. So circles were lessons 4, 5, and 6. A circle equation had center. We called it center HK, and it has a radius, and we call the radius R. And our formula for circles was x minus h squared plus y minus k squared equals r squared. So for this circle, for instance, when I see y squared in my head, I know that's just y minus 0 squared. So for example, I know that my center is the opposite of what I see. So my center here would be 1, 0. And my radius, this is my r squared in my formula. So my radius would be 3. And you can try the other two and check your answers in the locker. So now to write the equation of this circle, this is my center HK, this is my radius R, so I plug it into my formula, x minus 1 squared plus r minus k squared equals my radius squared. And you can write that as 49 or leave it as 7 squared, it's fine. You'd be done there. We haven't been asked to do anything else with it. Basic. The next question is also basic. Next week we'll get back into completing the square again, but right now this one's kind of halfway done for us. It's asking us to rewrite this as an x binomial squared and rewrite this one as my y binomial squared, and then rewrite this then as my radius squared. So play with this guy. Remember how we can write that. I take the square root, I would get my x, I'd get my 4, it's negative because of the middle term. So see if you can set that up, and then once you do, you can pick out your center and radius. So on the last page, this circle, this is also, I believe it's like a lesson problem and a homework problem. I'm sorry I don't have it off the just the top of my mind. But to graph this, we need our center and we need our radius, and we could graph it, and we can use our radius. It's going to go off. It'll go off over here and off over here. Then you'll pencil in the circle. So you have 3 different ways to figure out if 4, 0 is on this circle. One way is to plug in 4 for your x, 0 for your y, and see if that point makes my circle equation true. If it does, it's on the circle. If it doesn't, it's not on the circle. A second way to do this is to use the distance formula between the center is 2, 1, and the point 4, 0. So I would find the distance between these two, and I would see if the distance formula gives me the same answer as the radius. Remember, the distance formula is the square root, the difference in my x coordinates squared, plus the difference in my y coordinates squared, and the square root of that would be that distance. And I want to see if that's equal to 5. And so then if I get a number that's 5, I know it's on the circle. Less than 5 tells me where the point might be, and greater than 5 also could tell me where the point might be, and that's what question B asks about. You can check your answers in the locker for more detail. So on question 16, it wants us basically to work backwards. It wants us to apply the distribution property, which is really my box method or my FOIL, whichever one that you're comfortable with using, to rearrange this so that I have this all multiplied out and equal to 0. So you're going to use either box method or FOIL to get your x squared plus 2x plus 1. You'll do the same thing here, and then equals, you'll have your 9 right there. And then you'll move everything around so that you have it equal to 0 and all the terms on the other side of the equation. That answer is also in the locker. And then lastly, there's several different ways you can answer number 17, but think so far about what we know from lessons 1 through 14 actually, but lessons 1 through 8, think about what do you see when you look at an equation of a line? How do you know that's a line versus a circle versus a parabola? So consider those questions when you answer this, and know that my answer in the locker is one way to think about it, but there is other ways to think about it. And that is a few ideas and tips to do review 1 through 8. Thank you very much, and I'll talk to you in office hours or via email. Thanks.